So yes, these will be posted on YouTube. There will be a link to the YouTube channel on Canvas. Now, the physiology lecture section is divided up into 2 labs. So there's a Monday lab and a Wednesday lab. So make sure you're looking at the Wednesday lab videos and due dates and that sort of stuff, because there are going to be some differences in what weeks you do assignments versus what weeks Monday does assignments, because there's some Monday holidays. So just keep that in your mind while we're going through this. One of the first things that we're going to do is we're going to start doing breakout groups. I like to do breakout groups. It gives you a chance to meet your lab mates, even though we're on Zoom here. So today I'm going to divide you up into groups, and I want you to make a new friend. Find out their name, their pronouns, and find something you have in common with them other than being a college student. So I'm going to put you guys in some breakout rooms, and I'm going to give you about 5 minutes to make a new friend. Hi there, we're in breakout groups. So I'm going to add you to a breakout group, and just as soon as I can figure out how to do that.
Okay, got it.
recorded.
Okay, looks like we're all back. Does anybody want to introduce their new friends to the class?
Sure. I met Marissa and Tanya. Marissa, she's a bartender, and Tanya, she works at CMH.
Okay, great. Thank you.
All right, I'll go. I met Jeanette and Anya. They want to go into the nursing program and reach the master's level of nurse practitioner.
Awesome. Great. Anybody else like to go?
Yeah, I met Josephine. She also wants to be a nurse and get in the nursing program.
Great. That's awesome. All right. And now that we're all here, before we get into the meat of things, while we're doing Zoom and once we get into lab, I always start with announcements. They might be on the whiteboard in the classroom once we get into the lab, but for now, they're just going to be here on the screen. This week, there are 2 assignments. They are under the Lab 1 module on our Canvas site, and they're both due before midnight on Sunday, January 16th. On Friday, I will post the material for next week's lab, and there will be a pre-lab assignment, and that's going to be posted. That's going to be due before midnight on Tuesday before lab, so Tuesday the 18th. That's going to be kind of a trend. I'll get the next week's lab up on Friday, and there will be a pre-lab that you need to do before coming to the next lab. Most of the time, you may do it online or you may do it in person. That's going to vary throughout the semester. So the lab portion of physiology is about 25% of your grade. And it consists of 4 categories of assignments. The pre-lab assignments are worth 5 points each. We're only counting the top 10. So there's more pre-labs than that in the semester, and we'll just drop the lowest ones. So if you miss a lab, we're dropping that pre-lab and that lab assignment. Some weeks there is going to be an assignment. Until we get in person, it's going to be assignments. Once we get in person, we're going to talk about keeping a lab notebook. I will grade lab notebooks twice during the semester. I will collect them the lab before spring break, and then again close to the end of the semester. And the entries for each lab in the lab notebook or the assignment, if we have an assignment instead, those are also 5 points each. We're going to have 2 labs. I'm sorry, 2 exams. Those are 50 points each. And then there's also going to be a student design experiment that you're going to present to the lab, kind of at the very end of the semester. And we'll go into a lot more detail on that one when we get closer to it. That's not going to happen for a while. When you're writing in your lab notebook, this information is on Canvas. What I want to see is on the first page of the lab, a title at the top, underlined. I generally recommend leaving the rest of that page blank so that you can take notes on it. On the second page at the top, write materials and methods, underline it. Materials and methods are clear information about how you did the lab. So you'll have instructions given to you, but sometimes there will be changes to those instructions, or you may do something wrong. I want you to write what you actually do in the materials and methods. Notice that you're not going to lose any points for this. If you do a lab experiment and the experiment absolutely fails, that's okay. Experiments fail. That's normal in science. The next section are your results. And the last section is a discussion. In general, what did you learn from this lab? And there may be prompts. I may give you a suggestion about what I want you to say. And sometimes it's just going to be, kind of a reflection on what you learned in the lab. Now, I'm sure you've looked at the Canvas page. If you haven't, this is the course Canvas page. This is my version. Yours is going to look slightly different. So here is the general lab information, lab notebook instructions. Here is your lab schedule, lab Zoom information, and here will be a link to the YouTube sites where I will post these recorded Zoom sessions. This lab, it's basically set up to be done completely remote, but because we're doing this on Zoom and we're meeting at the same time, we are going to go through most of this lab as a class, and we're going to do parts of it as a class. Your assignments are at the bottom, and a copy of my PowerPoint notes are also here. Lab 2, this is not yet available for you, but that's the lab we're going to do next week. So you'll see this posted probably on Friday. Are there any questions on any of this so far? Okay. One more thing before we get going. I've had quite a diverse background in science. So I've done all kinds of different things. I've taught, I've worked as a field biologist, I've worked as a virologist, I've worked in molecular biology, and I have over a decade of teaching experience at the community college level. I am a first-generation college student, which means that I basically worked and put myself through college. I'm sure a lot of you guys are doing the same thing. It was a little easier to do when I was doing it. It just keeps getting harder and harder. But I want you to know that I do not care what your skin color is. I do not care who you love. I do not care what your religion is, if you have a religion. I do not care what country you were born in. None of that matters unless it is interfering with your education process. If you're having a problem either in lab or outside of lab that is interfering with your educational experience, feel free to reach out to me. I know a lot of resources that are available for students that can help you be successful in your education. So I try very hard to be equitable with all of my students. I try very hard to be supportive of all of my students. Please, please, if you're having trouble, talk to me about it, because there are solutions. And with that, let's get into the meat of the lab. So this is a science course. What is science? Does anybody know? It's one of those words that we all have kind of a vague idea what it means. We think we know, but when it comes time to explain it, oh, not so much.
Measurable, testable, repeatable, something like that.
Yes, that's very important part of science. Measurable, testable, repeatable. That's not really a definition, however, those are characteristics of science. The definition I like is that science is an evidence-based understanding of the natural world. It's a process for understanding. So there are other ways that people try and understand the world, through art, through philosophy, through religion, through literature. The difference with science is that it is evidence-based. And it's also being constantly updated and refined. We don't ever say in science, we understand everything about DNA. We know everything about DNA. We're never going to say that. We're going to say, we know all of these things about DNA, but if somebody finds something else out, we just add that to the list, because the world is a very complicated place. When we talk about science, we use these three words: hypothesis, law, and theory. Does anybody want to try and define those? Or one of them? Okay. Then I will do this. An hypothesis is an educated guess. It is what you think will happen. So my hypothesis is that sometime in the next hour, one of my cats is going to jump up on the desk and stick his butt in the camera. I have evidence this has happened before, and my hypothesis is it will probably happen during lab. There's very little support that will happen, right? There's very little evidence saying absolutely this will happen. It's my educated guess. Oh, I forget that it does that. What about a law? You've heard about laws, I assume. Laws of gravity, right? What makes a law different from a hypothesis or a theory?
Definitive statements based on fact.
Definitive. Boy, you gave me a word I'm not quite sure how to spell. Definitive statements. Yeah, laws are definitive statements. It is a statement about what happens. So the law of gravity says that if we drop something, it will fall to the earth. Anything that's made up of matter is going to be attracted to other things that are made of matter. And the bigger object is going to have more force on the smaller object. It's complicated physics going on here, but we all agree, right? You drop a bowling ball, it's going to hit the ground. You drop your pencil, it's going to hit the ground. That is how we define a law. What a law does not say is why. Why do things fall to the ground? What is going on that causes that? And that's where we get to theories. A theory explains why or how something happens. And there is a lot of evidence in support of this. So this is a problematic term in science, because if you are hanging out with your friends, you might go, I have a theory, and just be like, there is intelligence life out in the universe, but it's hiding from us. There's no evidence to support that. It's not a scientific theory. But because that's the common way of using that term, people often get confused when you say the theory of evolution. They think that means there's not a lot of evidence in support of it, when there's actually quite a bit of evidence in support of evolution, and it's probably better understood than how gravity works at this point. So it's important to remember what theory means in science class versus what it means when you're hanging with your friends. Is that clear to everybody? Okay. All right, so let's talk a little bit more about science, because this lab is all about how science is done and the so-called scientific method. So science can be divided into these two major categories: observational science and experimental science. So observation, it's exactly what it says. It's observing the natural world trying to answer questions. So Dr. Newsom in this picture is a well-known ornithologist. She studies birds, and she studies birds by going out and watching them and doing things like measuring weights and looking at feather damage. I think her work was actually on nest predation of a grassland bird. So who's eating the babies out of the nest? And she did that by setting up cameras and observing. Lots of wildlife biology is done this way. Geology is done this way. This is done when it is impractical or unethical to do experiments. So if you want to know how the giant sequoia trees are going to do with climate change, you really kind of have to observe them and watch how they're doing. You can't take a bunch of giant sequoia trees and transplant them into giant greenhouses where you change the temperature and the rainfall. It's impractical to do that. Some experiments are also unethical. For example, there is a myth that having an abortion increases a woman's risk of breast cancer. I'll tell you right now, it's not true. We know it's not true because of observational research. You take two groups of women, some of whom have had an abortion and the others have not, and you match them by age and socioeconomic status, and you look at the rates of breast cancer, and they're essentially the same. Ethically, it's not ethical to force women to get pregnant and have abortions in order to study this. So you use observational approaches. Most children do this instinctively. Children are natural scientists, and they observe the world around them, trying to figure out what's going on. Scientists are those of us who just never quite grew out of that. Experimental research is doing experiments. It is modifying conditions. So you modify conditions and see what happens. This can be things like discovering new drugs, figuring out the role of certain genes. Non-scientists can do this too. You inherited a recipe from your grandma for chocolate chip cookies. And you think, I wonder if this would be improved by adding nuts or using butter instead of margarine. And you try it and you see what's happening. That's doing an experiment at home. We all do these. We just don't think of them that way. Now, you've probably heard about the scientific method. And I'm going to go through the steps of it, but I want to state that this is not completely accurate for how science is done. So it starts with making an observation or identifying a problem. And then you have to do some background research. I want to know what the effect of phosphorus would be on the plants in my yard. Well, I can go online. I can go to Google Scholar or SciFinder and look and see what other people have done and see if my question's already been answered or if there's work that needs to continue to be done. And then come up with a hypothesis. What do you think is going to happen? Well, in my yard, I think adding phosphorus is going to end up killing plants. Then you do the experiment. I'm not actually going to do this. My previous homeowner, I've only lived in this house about a year, and the previous homeowner, I have no idea what they were doing, but when I did a soil test, the level of phosphorus in the soil is so high that it's toxic to a lot of plants. I don't know how you get that much phosphorus in the soil. They must have, I don't know, put down fertilizer every week or something. But in the lab, we would do an experiment and we'd analyze the data and ask the question, was the hypothesis supported? And then you report conclusions. In science, this is a formal process. You write up your conclusions in a specific format and send it off to a journal to try and get it published. Your journal sends your paper to other people who are experts in the field. This is called peer review. And they will read your experiment, look at your results, look at your conclusions, and they will give you feedback. Sometimes the feedback is very minor. You know, oh, I think you need to present this data in a different type of graph, for example. Sometimes it's more serious. I really think you need to do more experiments to support your conclusions. Sometimes it just gets rejected. This is good science. This is a check system on information before it is published in scientific journals. Ideally, that's the way science works. Now, this scientific method is kind of a framework to figure out the process that you would need to go through to do some kind of experiment. But like I said, it's often not the way things work. A lot of times what happens is you do an experiment, you look at the data, and you go, I'm not quite sure what's going on, so I'm going to go back and I'm going to read some more papers and come up with a new hypothesis, do some new experiments, and so on and so forth. And inevitably, when you get to this point and you report your conclusions, there's something else that has kind of caught your attention that you then say, well, that was weird. I don't know why that happened. Those are the best kinds of moments in science when you go, I don't know what's going on there. And then you get to find out. So when we set up an experiment, ideally, we're going to divide whatever we're studying into two groups, a control group and an experimental group. These two groups are going to be treated the same, except for one variable. So say you have heard that zinc cures colds. Is it true? Is it not true? Let's do the experiment. We find a bunch of people about the same age, about the same health, who all have a cold. One group, the experimental group, would get treated with zinc. The control group would get treated with a placebo. So if say you're using a nasal spray with zinc in it, they would have a nasal spray without zinc. If it was a pill, they would have a pill that doesn't have the zinc. Everything else, it stays the same between the two groups. We have control variables. And if we're talking about studying a cold, the other variables will be things like age, general health, other medications. Those are the things that you would keep consistent between your two groups. The variable that you change, this variable is the independent variable. The dependent variable is what you are measuring. If you're looking at colds, maybe you want to measure how long people are sick for. That's one thing you can do. All right. Does anybody have questions or comments at this point? Okay. So what we're going to do, I'm going to walk through this scenario kind of as a group discussion and demonstration. And then we're going to have another scenario that you guys are going to do in breakout groups. All right. Jacques loves roses. He wants to beat his arch nemesis Bill in this year's rose growing competition. The winner is chosen based on how large the rose blossoms are. Jacques has read that phosphorus content in the soil can affect rose blossom size. Jacques wants to see if this is true, and he really wants to defeat Bill next year. In order for Jacques to perform a scientific experiment, he needs to first identify the one thing he will change, the one thing that's going to be different between his control and experimental groups. He will then identify the one thing he will observe as an outcome. He's going to have different roses in the control and experimental group so he can compare the outcomes. So with these two questions, what is the one thing Jacques will manipulate in his rose garden? Someone want to chime in?
The phosphorus content?
The phosphorus content of the soil, exactly. And what is he going to observe and measure?
The size of the bloom.
Size of the bloom, exactly. So the phosphorus content is the independent variable. The size of the bloom is the dependent variable because the size of the bloom is going to theoretically depend on the amount of phosphorus in the soil. All right, so I just defined the independent and the dependent variable for you guys. What would be a good hypothesis for this experiment? What do you think is going to happen?
An increased amount of phosphorus will increase the size of the bloom of the roses.
Yeah, really good. Yep. Increased phosphorus will result in larger blooms. what is our experimental group going to be? Okay. The experimental group is the roses in higher phosphorus soil. And the control group, roses in normal soil. Now, we are missing one question here. So when we talk about controls or controlled variables, these are the things that we're keeping consistent between the two groups. So what kinds of things might be controlled variables?
Time under sunlight.
Yep, that's
On
good.
water.
Water, yep.
The type of roses?
Type of roses, great. Anything else you can think of?
Maybe where you plant the roses?
Yeah, where you plant them. Because temperature is also going to matter. You can't compare roses planted in California with roses planted in Massachusetts, where I think it's supposed to be like 16 degrees today. So yeah, these are all things that are controlled variables. All right. So these 6 questions we're going to come back to. So if you haven't written them down, take a quick picture of them on your on the screen. So this one, let me add that 6 questions. I'm going to read this one to you and then I'm going to send you into breakout groups to answer these questions as a group or as groups. Kian loves Coca-Cola. He drinks 4 cans of Coke per day. He is also several kilograms above his target body weight, according to his doctor. Kian wants to perform an experiment on himself to see if switching to Diet Coke can help him lose weight. Could we set up an experiment to see if switching to Diet Coke will help Kian lose weight? So I want you to answer these questions and come up with an idea for how you would set up this experiment. And unfortunately, I have to close this screen to send you guys into breakout groups. All right, I'm going to give you guys a whole 10 minutes to discuss this one. You probably won't need that long. I heard you walking around. Were you okay with your badge?
Yes. approaching this tonight. Wanted to make a breakout session.
Okay, thank you. Let's consider it. I think bananas are on there. Almond milk should be on there. If yogurt isn't. Let's have yogurt. Okay. Okay, looks like everybody's back. So let's see how that went. In this scenario, what is the independent variable?
Drinking the Diet Coke.
Yep, the Diet Coke, exactly. What is going to be the dependent variable?
The weight loss.
Right, the weight, hopefully loss. Somebody have a good hypothesis for this experiment?
Drinking Diet Coke versus regular Coke will result in weight loss.
Yeah, that's good. Yeah, I like the fact that you indicated that it's drinking the Diet Coke in place of regular Coke and not just drinking Diet Coke. That was good. What would be our experimental group? This one's a little tricky.
Is it drinking the Diet Coke?
Yep, actually, yeah, the experimental group, drinking the Diet Coke. Yep, exactly. And so the control group would be?
Kian's
The regular
regular Coke.
Yep. And the last question, which wasn't written up here, what would be the control variables?
Would that be like his normal routine staying the same outside of drinking the Coke, so nothing affects the results?
Yeah, so could you be more?
Maintaining his physical activity on the regular Coke.
Same amount of exercise? Anything else?
Same amount of calories intaken every day, eating.
Yeah, really good. That's perfect. Okay. Sounds like you guys are getting the hang of this. We're going to go through one more scenario, and then we're going to wrap it up for the day once I tell you what once I remind you what your homework is. So Mariah is studying for her physiology exam. The textbook states that eating large amounts of sodium will cause the kidneys to excrete more sodium in the urine. So you need to answer the questions, but then you also need to design an experiment. How would you test this? And I'm going to mix up the breakout groups and give you guys another 10 minutes. Again, you probably won't need it, but I'll give you the whole 10 just in case. Okay, I think we're all back now. So need to find my annotate button. What is the experimental variable in this scenario?
The amount of sodium intake.
Yep, sodium intake. You guys have learned that sodium is Na, right? Yep. Okay, good. And what is the dependent variable? What are you measuring?
Sodium in the urine.
Yep. Perfect. And what would be your hypothesis?
Increased sodium intake increases the concentration of sodium in the urine.
Yep, perfect. So describe your experimental group.
The people eating more sodium, I guess.
Yep. Perfect. And the control group?
The normal amount of sodium.
Yeah. What do we have to keep controlled? What are the variables that need to be the same between the two groups?
Alcohol consumption.
Alcohol, that's a good one.
Water consumption.
Yep. Anything that's going to affect hydration will affect your urine. Exactly.
Exercise.
Exercise. How about age and health? Anytime you're studying people, you need to keep these things consistent. You don't want.
Medication.
Oh, yeah, good one. Yeah, you don't want a bunch of people who are old and already have failing kidneys and compare that to a bunch of 20 somethings. You're going to see a difference there.
Would the food intake be one?
Yeah. Good, good. You guys have this down. So how would you set this up? We've got all the information here for how to design this experiment.
I'm just gonna take a guess. So, considering everything like the medication, the food, the water, or whatever, just make sure you're consuming the same exact things. The only thing that will change would be adding more sodium versus the other.
Yeah, that's basically it. You're going to get a group of people, make sure those controlled variables are the same, give half of them extra sodium, the other half a placebo, and then compare the sodium levels in the urine. It's exactly right. Okay. And the timing worked out pretty good. So I didn't mention this at the beginning. What we're going to be doing for the next few weeks, we're going to be meeting on Zoom for between 90 minutes and 2 hours, doing this kind of thing with breakout groups. And then once we get back in lab, of course, everything's going to be different. So for this week, there are 2 assignments. They're very similar to what we just did in our breakout groups. Make sure you complete both parts before Sunday, January 18th, before midnight. And does anybody have any last minute questions before I let you go?
Yeah, Professor, I got a question. So these scenarios that we are, or experiments that we are writing down, are these what we're going to put into that notebook that you're going to check? Is that part of the log, or?
Because we're remote, I'm giving you assignments rather than having you write in a notebook.
Okay, all right, that makes sense.
We'll start the notebook when we start meeting in person.
Okay, so don't worry about that yet.
Yep,
Okay.
exactly.
Thanks.
You're welcome. If there's nothing else, I will see you guys next week.
Thank you, Professor.
You're welcome.
Thank you.
Yeah, thank you.
Bye.